Good afternoon, and thanks for taking time on a kind of short notice to attend this information, basically webinar. We have several opportunities for internship for our students at FIU, and so the objective of this webinar is really to provide you with information and tell you about who we are, what we do, and tell you the story. And hopefully, some of you are going to be interested to work with our faculty on the research projects that we have. So, some of you may know by now that U.S. Department of Transportation just recently in February, late February 2023, selected the Florida International University as a lead university to lead a Tier 1 University Transportation Center devoted to bridge engineering. I must say, although there are few others that are in the area of the infrastructure, but this is the only university transportation center that USDOT selected to focus on bridge engineering. What is even more, I think, interesting or important, really, from our viewpoints, is the fact that we are one of the only 4 universities that they have been continuously won the competition in 2013 competition, 2016, and now 2023. In 2013, for the first time, USDOT selected the Accelerated Bridge Construction University Transportation Center with FIU to be the lead. At that time, we had Iowa State University and University of Nebraska-Lincoln as our partner universities. And let me give you just a little bit of a background. What is UTC's? University Transportation Center is a program that is funded and organized by U.S. Department of Transportation. It's a part of the language that's in the bill, in the Congress has approved it, that every year USDOT on a very competitive basis have to select 5 national university transportation centers, 10 regional, and 20 Tier 1 university transportation center. Every one of these university transportation center focuses on different areas. Some are in traditional transportation, traffic, ITS, safety, mobility, and so on. There are few of them that are in the infrastructure area, and we are the only one really with the focus on just the bridge engineering. I will give you some background on what we are going to be doing. During the 2013 competition and 2016 and the 2023, there were more than 200 proposals that were submitted actually to this competition. So it's extremely competitive. Each proposal consists of one university taking a lead and several universities being a partner. So it takes a very long time. It's a very competitive and it's very prestigious. And sometimes really it's not so much money that we are going to be getting from the USDOT or we have got from USDOT. But the most important aspect of this for our student is the fact that when they are associated with the University Transportation Center, they can put that in their resume and everybody knows who we are. And it enhances our student that is working with us to get a job because people, we are very visible through many different programs that we have, and I'll give you an example of it. So you will see it. Okay, so it's a great opportunity. Sometimes it's easy to miss great opportunities, and this is something that's at FIU, and it's something that it will give you also the opportunity to get experiences in case you want to go to the graduate school for master degree, or if you're a master degree student, you want to go get a PhD. So in that sense, it's a great opportunity. So let me, with that, I mentioned that to you. These are the list of the universities. So FIU is the lead university. Florida A&M and Florida State University, that they have a combined College of Engineering, they are one of our partner universities. University of Georgia is one of our partner universities. Texas A&M is one of our partner universities. University of Nevada, Reno is our partner. University of Oklahoma, University of Washington in Seattle, University of Georgia. I mentioned the University of Georgia, I guess, twice there. So this also provides you with the opportunity to interact with these other universities too. So we have annual meetings, we have conferences, and you get exposed. If you have a question, if you're conducting a research, you need some expertise, and if you don't have it here in FIU, you can look it up, and any one of these partner universities, it makes it much easier to contact them on a number of different issues. So why do we concentrate on the bridge engineering? I must also say that up to now, we were only concentrated on the accelerated bridge construction, which is a form of constructing bridge, which means, contrary to what you guys see in the mass media, they think that accelerated bridge construction is doing a shortcut. It's not a shortcut. All we are doing is, in fact, the total construction time of building a bridge is same or even more than conventional case. All it is, let's say, for example, if you want to build a bridge, what do? You have to close the lanes, you have to close the traffics during certain time of the construction, and that causes a traffic jam. It causes accident because construction zones usually are magnet or accident. And so there is lots of interruption to people's daily life. People get, actually health-wise, it's not very good. You guys can relate to that when you are stuck in the traffic jam for hours and hours. So now this problem actually becomes a little more serious considering the fact that we have 617,000 bridges in the US, but 42% of them, okay, 42%, say about half of them, are gonna reach their 50-year design life that they were designed for. Now, there's a difference between design and service life, but their design life, which means that we designed them for the type of the traffic that we kind of guessed that over the next 50 years, what's going to be. We designed it for that, for the type of the traffic that we thought it's going to be. And about half of our bridges in our inventory is going to need some action, or the repair, retrofit, replacement. Now, imagine all these construction activities, what it's going to do to the society. That's why the AVC was important, and that's why 2013, 2016, we concentrate on AVC. What we are going to do this time, we are going to go beyond accelerated bridge construction. Just for your information, in the US, of course, when you look at the economy, our economy is #1 in the world. But if you look at the quality of our infrastructure, we are barely number 13. So what the government and the US Department of Transportation wants, these UTCs, each one of them having different mission, to make the industry in the US very competitive. In the case of the bridge engineering, our task is to make sure that the bridge engineering is absolutely number one in the world. How do you do that? It doesn't happen just by advertisement, by marketing, things like that. It doesn't happen that way. It happens by technology. So that's why this time our task is to bring all type of advanced technologies into the bridge engineering in the US and communicate that with the basically our stakeholders, with the bridge owners, state DOTs, municipalities, and so on. So that's why the type of the research that we're going to do is going to be so interesting. We're going to be multidisciplinary. We're going to go and have our faculty that work with us closely, okay, most of them, to tell you about their areas of research. And then at the end, I will come back and I will show you a couple of areas that I work myself. But before doing that, okay, I want to show you just a video clip that hopefully will tell you how influential we are with the bridge owners across the US. Okay, and to do that, what I'm going to do is, if you allow me, I'm going to show you just a very short videotape, a video recording that is one of our conferences that happened to be in 2019, and that really shows you that our connections, how we connect with the industry, okay, and what kind of influence we have. Okay, so with that, let me show you this piece of video. It's about 2.5, 3 minutes, and then we're going to go to our faculty, so you will see what kind of research they do, and I encourage you to directly go to them. Once you see what kind of research they do, go to them directly and see what they are doing, see what opportunities they have, and more importantly, also follow the development in the case of our University Transportation Center, because there are lots of opportunities for you. So let me show you this short video, okay? So this is a short video that was highlights of our 2019 international conference. We had it in 2022 as well. 2021 was a virtual. We had 2014, 15, 17, 19, 21, 22. So this is hopefully you guys hear the song, by the way?
Yes.
Welcome to 2019 International Accelerated Bridge Construction Conference. And very warm welcome to more than 600 people standing over here and seeing all these colleagues and all these bridge engineers in one room. Isn't that beautiful?
We see ourselves as an institution, as a solution center for the community. One of our preeminent areas is accelerated bridge construction.
EDC is a state-based model that identifies and deploys proven yet underutilized innovations, saving time, money, and resources.
This conference is for all bridge professionals to educate them and allow them to share experiences. It's a very good platform for people to develop networks.
Welcome, Dr. Eugene Luo.
This conference was different from the first three. It took on an international perspective.
It's a great pleasure for me to present some of the works we are doing in Europe.
We started the conference by having 7 workshops, followed by 108 technical presentations by different stakeholders within the bridge community. In our technical program, we included 4 keynote talks covering important topics within the ADC.
We need to develop such materials that will provide much better properties than just ordinary UHPs.
The Asheville Earthy Guide Spec covers all aspects of design and construction for ABC.
It's called a Guide for Service Life Design. Bridge designers today can take this guide and start using it immediately.
Within the next decade, we are going to be able to print elements of the bridge on site.
We have exhibitors with the latest in innovations, materials, and technologies to support the ABC implementation effort. We have all the experts, those who are making things happen in ABC around the country here. You can talk with them on a one-to-one basis. It's a great opportunity for anyone in the bridge community to participate.
This year's conference is great. There's more attendees than before. It's been very good. We had a lot of traffic at our booth, so we're happy with that, and definitely met a lot of quality people.
This is a great conference. Not only are we talking about theoretical use of accelerated bridge, it's actually a lot of practical solutions.
Whether you are integrated with your ABC and just how you do business, whether you're just starting out, whether you want to advance what you're doing, this conference offers opportunities in a variety of areas. Great networking. The content of the presentations has been fantastic. And really, I've gotten a whole lot out of the exhibit hall as well, interacting with the exhibitors. So I definitely recommend attending the conference.
The award program provides an opportunity to showcase innovative projects and to recognize talented individuals that advance ABC.
I think it's important to acknowledge what the industry is doing, and I think we need to continue to highlight people and projects just for the sake of ABC becoming common practice. We need to get it involved in every project. It's the right thing to do. It minimizes impacts to the public. It improves safety. It improves quality, and it makes me really proud to get this award because I know I was doing the right thing.
Our next conference is going to be in December of 2000. All right. So with that introduction, let's, Eda, would you go through the, let me just go there. So what we are going to do is have our, basically the faculty that work with the ABC UTC, or soon to be IBT/ABC UTC, to provide the areas that they're conducting research. Again, please approach them, follow them, see what they are doing, follow the news that we have in the UTC. So hopefully, you will take advantage of it. So with that introduction, let's go with our first faculty, Dr. Armin Mehrabi, to introduce the areas of the research. Armin, it's all yours.
Thank you very much, Dr. Aziz Namini. So again, my name is Armin Mehrabi. I work at ABC UTC Center, again, as Dr. And an extra point is that currently I'm also graduate program director. So for those of you who like to join our graduate program, I will be your first contact. And I will help you through going to graduate program. And if you are interested in any of the fields and topics that you see today, so we'll make it happen that you get internship or other positions with the center. So the areas that I work currently, and I have been working for last 30-some years, non-destructive testing and damage detection, one major area. Then from the new, let's say, relatively new materials in construction and bridge construction, especially the fiber reinforced polymers, composite. I currently have several projects in methods of splicing and connection structures. And sub to that, the minor areas, bridge inspection and maintenance, basically, structural health monitoring, field and laboratory structure testing, and advanced analytical models like finite element modeling, etc. So the work my team has been doing partly involved with field work, which is really good. I personally am excited when I'm on the bridge site and doing work on the bridge. I'm sure many others are. So that involves testing, load testing, non-destructive testing. Some of them advanced. The one you see on the right side, the picture, is using a laser for detection of damage in bridges. Again, my team, which is part of ABC UTC or IBT ABC UTC, has possesses, that's the important thing. So we have in our group most of the major non-destructive testing methods available and devices, including GPRs, drones, lasers, thermal imaging, etc. So we are kind of reaching that aspect, fortunately. Just a couple of projects that I've worked as an example of what we have been doing. One is that is very dear to me and my team, is a project that we did exactly for the ABC UTC, looking for alternative materials and configurations for pre-stressed precast concrete pile splicing connection. Basically, to connect to splice the piles that come to the field for driving into the soil. So we went ahead with this project. It gave us a lot of products, including methods and means that not only applicable to the piles, but to this all structural prismatic elements as well. So this is a sample of how ABC UTC or IBT ABC UTC can help any topic that people are interested to get to the maximum potential of it. So as part of that project, we proposed 3 different new connection methods: grouted sleeve splice for prismatic elements, and splices using fiber reinforced polymers, FRP, and we received 3 patents on this product. So that's amazing. During the life of the project, it was a year and a half, 2 years, we received 3 patents. Another project that I'm doing for Federal Highway Administration, developing a guide for field inspection of in-service FRP, fiber reinforced polymer, reinforced strengthened concrete bridge elements. Interestingly, there is, after so much done for inspection and NDT testing, there is no guide for field inspection of concrete elements that use FRP element. So our team took over developing this guide. That project, in addition to analytical work and review of other works, we also constructed several specimens, as you can see. I want to include this picture that our work includes lab testing, field testing, analytical, etc. So to give you a picture of what really is going on in these projects. And I mean, these pictures that you see is really top of the work. So you see on the left side, glass fiber reinforced polymers that was put in the concrete, and the concrete was cast on it and embedded. And below you can see that GPR is detecting that glass fiber reinforced polymers inside the concrete. So the significance of it, not only that we have been able to detect steel, etc., in the concrete, but this is the first time this is being done, detecting plastic, non-metallic elements. And on the right side, you can see as of external application of FRP, you see on the top application of carbon fiber sheet for strengthening. And below that, you see a thermal image of that surface, shows exactly where the damages are. So these are just a few examples that I included to give you an idea what's going on with our center and specifically in my group. So as Dr. Aziz Namini mentioned, Anybody interested in any of these or others, please get in touch with me and other faculty. We will be more than happy to help you through the decision making. Thank
All
you.
right. Thank you, Armin. Thank you, Armin. So we're going to go to next to Dr. Ali Ibrahimian, who is faculty in Civil and Environmental Engineering Department in the Water Resources area. Ali, it's all yours.
All right, thank you. So good afternoon, everyone, and thank you for the opportunity for me to present here. My name is Ali Ibrahimian. I'm an assistant professor in the CEE department. My major area is water resources engineering. My expertise is mostly in stormwater hydrology and water resources management, with the extension to all the management and planning of civil engineering infrastructure systems. So the fact that I'm presenting here today is for our students, if you want to get involved with the ABC, UTC, or the IBT Innovative Bridge Technologies Center, you don't have to be a structural engineer, or you don't have to be a traffic engineer, because as Dr. Azizi mentioned, this is really beyond the structural engineering or traffic engineering. This is really a multidisciplinary center. And it actually, like any other real-world engineering problem, this has a lot of angles. So we need a lot of people with different backgrounds to work together to be able to solve our problems. So what I'm presenting here today is just a couple of examples to show you how I have used my expertise, which is not in structural engineering, to address some of the needs and issues with accelerated bridge construction. So the first project that I worked for the ABC UTC was to develop a decision support tool for the prioritization of accelerated bridge construction, basically for rehabilitation projects, not for new construction projects. So we have more than 600,000 bridges in the country. More than 25% of them need some sort of rehabilitation. As Dr. Azizi mentioned in the introduction part, about 42% of them are at the end of their typical 50-year design life. So we need a lot of rehabilitation. And obviously, as you could imagine, there's limited funding. So we do need to have some decision support tool to help our decision makers, FHWA or our state DOTs, to come up with the most important projects, with the most influential projects to work on. So in order to do that, we need to identify the different criteria that are important for this prioritization. And the current practice or the conventional practice is just to look at the structural condition of the bridges and also the traffic condition of the bridges. But the problem is really beyond the work zone area. So these bridges are actually affecting the social conditions and the environmental conditions in the area. And to be more exact, they are affecting social equity and environmental justice in our urban communities. So what we did in our first project was to identify the relationship between bridge construction projects or accelerated bridge construction projects, the benefits that the ABC can provide in terms of social equity and environmental justice, and to consider to incorporate these two factors together with our technical criteria, which is the structural condition of the bridge, which can be affected by the floods. Basically, urban floods are one of the most important causes of bridge failures in the country, mostly because of the scours that they cause in bridges. And then, so you see that these are kind of multidisciplinary problems. In order to develop that decision support tool, you need to have some sort of flood estimation or flood modeling. So that's just one part. The other part, you need to work with big data. By big data, I mean the data related to structural, traffic, and social data, environmental data. So these are really, interdisciplinary projects. And we also need to put together or develop GIS-based tool, because these are spatial problems. We are looking at different parts of a region, of a city, and each part have their own characteristics. So this was the work that we did for the existing project. As part of that project, as you see, for example, we had to work on kind of a sub-project, which was improving the flood mapping in urban areas using image processing, using satellite images, and improve that flood mapping using machine learning techniques. So these are like sub-projects that we had to define under the actual project. And the picture that you see in the bottom right is the final product. As you see, this is a color-coded map. Each circle on this map is a bridge in Miami-Dade County. You probably are familiar with this area. And the different colors are showing different risks for each bridge. And this risk is just an integrated factor of all the criteria that I just explained to you. So we are currently doing another project, which is about the new construction projects. So there are a lot of common concepts between the projects, but for the new one, we are looking at how we can incorporate safety, how we can incorporate social factors and environmental justice in determining what project is really a good candidate for ABC. So I have another slide for you. So these two projects was kind of the projects that we have been working on. And this is just to give you some ideas for the future. For the new center, or the extension of the ABC UTC, which is the Innovative Bridge Technologies, we are really looking at out of the box. We are looking at, the related technologies that can affect that and are working with bridge technologies. And just to give you a couple examples, one idea is to have climate resilient bridges. So you have heard about climate change effects in different parts of the country. And basically each part of our country is being affected by different aspects of climate change. It could be extreme floods, sea level rise, excessive heat, wildfire, mostly in the West. And these are disproportionately affecting people. So social equity and environmental justice are also. So the problem here is how to understand the linkages between our bridge system and these different, effects of climate change, and how we can address these issues in our projects. So this is basically a multi-scale problem. First of all, we need to understand the linkages between these problems. This is like a system of systems problem, because each of these factors is actually a system itself, a complex system itself. So this work, as you could imagine, includes a lot of planning, field work, sensor-based monitoring, and also modeling and design. So these are the ideas. I'm just giving our students some ideas. If you are interested in any of these ideas, these are the ideas that can be done in this project. And then just as an example, my basic area is green stormwater infrastructure. We do a lot of field monitoring, sensor-based field monitoring to look at the performance of green infrastructure systems. But these green infrastructure systems can be integrated to bridge projects to address, for example, the stormwater pollution that we get from these systems, and to address the urban heat island that is being increased because of adding our bridges. So we can integrate these green technologies to our bridge project to kind of, address the climate change issues. So with that, I thank you again for your attention. Please feel free to reach out if you feel connected to any of these areas that I explained to you. This is my email, and you probably know where my office is. So yes, please feel free to reach out. Thank you.
Well, thank you, Ali. So as you can see, really, the center is way beyond just the structural engineering. So the student who works as an intern, they will have a chance to experience different areas. Actually, to give you just some flavor of some idea on diversity of the type of the work that the center is going to do, then our next speaker, Dr. Mark Finlayson from the department of the School of the Computer, basically, is going to give a talk on the areas that he's working on. So there are several areas outside the actually the civil and environmental engineering department that really has a lots of influence on the future of the bridge engineering. And I always say the bridge engineering 10 years from now is going to look nothing like what we have at the present time. So Mark, it's all yours.
Yes, thank you, Adarad. So I apologize if my audio is a little bit wonky here. I'm in a very awkward spot. I happen to be in Germany, and it's a little bit later in the evening here. So apologize for that. And I don't have any slides, unfortunately, but what I can do is give you an overview of what I'm thinking about with regards to how AI can impact the center and how our undergraduates, our students can get involved in research. So I think there's basically two broad strands of work that I'm interested in supervising. The more specific strand, it has to do with my area of expertise, which is natural language processing. So I'm interested in understanding the structure of language, understanding how people use language, and how that reflects how people are thinking in social contexts. And bridges are built by people, and so social contexts are important in understanding how to build bridges effectively and how do you manage them properly. So I see a lot of potential applications for natural language processing in doing things like looking at design schematics, automating bridge safety report analysis, or learning lessons from reports or other sorts of information that is written in unstructured natural language. I think there's potentially some interesting work to be done on developing systems for processing specifications and regulations. So understanding how different regulations interact across the spectrum. So different jurisdictions have different regulations, and possibly automatically, assessing appropriateness of different projects for different locales would be a potentially interesting one. I think I already mentioned the idea of extracting lessons learned from safety reports. So when you have a failure of safety, as has happened in many construction projects in the past, then these get written up in reports, especially reports as those produced by, for example, the National Transportation Safety Board. And I think it would be really cool project to try and extract lessons about how to do things better in the future, but extract them automatically over large numbers of reports and synthesize those. So that's one strand of research that I think the center will be pursuing. The other strand is more general. So there's sort of general AI, right? So we've already seen some discussion of how machine learning can be used on some of the data. In terms of the work that I personally would be interested in supervising, I think there's some interesting work to be done on looking at surveying the field and how AI is actually being leveraged in construction engineering generally and bridge construction more specifically. And if we do this, we can actually, I think if we get a better view of what's being done out there, or what the cutting edge is, we can use that to inform our own work and drive forward the research at the center in a productive way. So that's what I was thinking in terms of student projects. So if anyone's interested in these ideas that I've thrown out there, we're very much at the early stages of concept formation for our projects. So please do reach out, and we can set interesting directions.
All right, thank you, Mark, and thanks for taking time and during your sabbatical joining us from Germany. So now we are going to go to one of our actually new and very promising faculty, Dr. Go, who is in transportation area. So to provide you with the very brief summary of the her expertise in the research area. So it's all yours.
Yeah, thank you for Dr. Radhilamini, your introduction. So really appreciate the chance to be able to introduce my research here. So my name is Chaewon Go. You can also call me Vivian. I'm the assistant professor in transportation engineering. Before I came here, I used to be a teaching professor at the Florida State University. For your better knowledge about my prior research, I would like to give you an overview of my research program. My research expertise is mathematical modeling and system optimization, especially mathematical programming. Since I have quite broad research interest in the planning, operation, and management of multimodal transportation system, I developed quite a few applications in several core areas of transportation, namely public transportation, civil infrastructure and development, smart and shared mobility, and transportation network resilience. As you know, transportation research is highly interdisciplinary research. I also borrowed the theory from the big data analytics and microeconomic and behavior science. So a few examples are briefly explained here. I have studied how transit lines should be extended over time. I study how to regulate and subsidize a transit operator from the government perspective. I also develop a transit like travel incentive scheme to encourage the traveler to use the public transport and nudge the dynamic carpooling participant to revise their predetermined travel schedule. So those studies have yielded more than 10 research papers published in the leading transportation journal, Transportation Research Part A, Part B, and Part C. So this is I'm very fascinating with many other transportation research topics. This is why the reason I plan to work on some several topics. If you are interested in, we can work together on this aspect. For example, this is the one research proposal I proposed to the Florida Department of Transportation. Right now is recommended by the Office of the Traffic and Transportation Engineering Office headquarters. So you can see on this research project, we propose we will use the hydronic model to generate near real-time 2D flooding in a nation map. And with the identification of the flooding road, that we were able to analyze the impacts of the those unpassable roads on the traffic condition. And we will further cultivate the GIS layer to show in the flooding factor and also along with the traffic condition. And these indicator will be further incorporated into the Florida Department of Transportation e-traffic website. And we will also propose to establish the flooding early warning system through the VMS system and the 511 system, so that can publish to the to have those warnings sending out to the public. So this is the one research projects I will work on in the future. And another one I'm also fascinated with is about the vehicle routing problem. So I proposed Drone Assist truck delivery in emergency response. We can develop an optimization model for delivery of multiple package of lightweight relief item for the emergency response use. For example, the vaccine or water purification tablets. So this lightweighting the item can be via drone to a certain numbers of remote location within a disaster-prone area. For example, if there's a hurricane came and result in some of the road link and road nodes become inaccessible, if we keep using the truck to deliver those emergency items, will be extremely difficult and it will cause a lot of delay. But instead of using the conventional truck, we can propose to use the Drone Assist truck. So I could further evaluate the advantage of Drone Assist truck delivery over the conventional truck delivery in the disaster mitigation phase. And we can develop a mathematical model to optimize the drone delivery in last mile distribution of emergency item. Consider the technical specification of drone, for example, the bacteria limits or the flight range of the drone, so that to help, and also we can under a different scenario circumstance, for example, a different category of hurricane can will result in different levels of the damage on the road network. And we can, with that information, we were able to optimize the best round of the truck combination with the drone delivery. So I think these are the major future research I plan to work on. So if you are interested in the above research or any other things like I previously published those research paper, I would love to work with you. Yeah, thank you.
Thank you,
for
Vivian.
that,
Thank you, Vivian. Great presentation. All right. So next we have actually Dr. Omar Nofal, was not able to join us live, but he recorded, I think, very briefly the areas of expertise that he has. I believe, Eda, do you have the recording to play?
Yes, I will play the recording now.
Hello, everyone. I am Omar Nofal. I'm an assistant professor at the Department of Civil and Environmental Engineering here at Florida International University. I just joined FIU last fall, the fall of 2022. Sorry that I wasn't able to attend in person, and I hope that you all will like the virtual presentation that I'm gonna present today. So I'm gonna present a little bit about my research portfolio and the research topics that I have been working on over the last few years. So I have done research at different levels and also in different topics. So I have done research at the component level, building level, community level, and also some other researches related to community resilience. So for component level analysis, early in my career, I have been doing research in earthquake engineering and the design of the coupled shear wall system, investigating the impact of the coupling beams on the behavior of the coupled shear walls under earth and lateral loads in general, including earthquake and wind loads. Also, I have done flood research at the community level. So we have been investigating the susceptibility and the vulnerability of the different building components under flood hazards. So we developed probabilistic functions that can capture the failure of the different building components under flooding. Also at the building level, we have developed vulnerability functions for a portfolio of building archetypes. Basically, fragility functions at the building level, it's kind of like capturing the performance of buildings, the total performance of buildings under flood hazard in terms of the exceedance probability of a specific damage states like slight damage, moderate damage, extensive or complete damage. And we have done this using single variable flood fragility functions, like developing only functions that can capture the performance of buildings under flood depths. And also we have multivariate flood fragility functions that can capture the combined impact of flood depths and flood duration on buildings. Also at the building level, we have done research at multi-hazard hurricane risk assessment. So we developed vulnerability functions that can capture the combined impact of surge wave and wind on the total performance of buildings and the damage to the different building components, including structural components, non-structural components, and also interior content. At the community level, we have done lots of research at the community level, investigating the regional impacts of flooding and hurricanes at the city level, county, and also state level analysis. We developed a portfolio of building archetypes that can model the different building typologies within the community and use this as an exposure models for flood and hurricanes and capture the impact of these natural hazards at the community level and provide results for the community at the building level, like providing the total damage for each building within the community. This also leads to community resilience analysis by integrating detailed information about the household living in each building, along with their socioeconomic characteristics, including age, income, race, ethnicity, age, so lots of information about the household, and working with other group of researchers from social science, economists, and also civil engineers from different disciplines, we were able to develop an interdependent model for the community with detailed networks, including power, water network, and also transportation network, and integrated with our social and physical model of the community that includes detailed building information and detailed household information. Then we use this model to capture the post-hazard functionality of the community following a natural hazards in terms of either buildings are damaged or not, a household has accessibility to essential services such as schools, hospitals, workplace, shopping centers. All these will not happen if we don't have detailed information about the community. Also, other research that I contributed to is conducting field studies to collect detailed field information after natural hazards. I have been part of a steer group who went to Fort Myers Beach to collect detailed damage information using street view data. And also I have been done field studies since 2016 after Hurricane Matthew, which hit North Carolina in 2016, and also after Hurricane Florence. So I have been in multiple field studies who were deployed in Lumberton, North Carolina. Also, I have done research in optimization to optimize the mitigation strategies for communities and identify the best mitigation mechanism that can fit each building within a community. Also, I have done research that includes engineering and economic models to predict the economic value of investing in advanced quantitative precipitation information system so that we can have a lead time before having a flood and see how this lead time can help to do some mitigation measures that can reduce the flood losses and see how the impact of these flood loss reduction on the economy. Also, I have been part of verification and validation of numerical models using a number of verification and validation methods. So this is in brief most of the research that I have been involved with over the last 6 years, and there's lots to come, but this is actually what I have to present for now, and thank you. And if you have any question, feel free to email me.
All right, okay. I believe Dr. Kingsley Lau is with us, right? Am I right?
Yes, I'm here.
Okay. Kingsley, would you like to kind of briefly go over your research project?
Sure. I have a few slides. I can share my screen.
Great.
So, hello, my name is Kingsley Lau. I'm an associate professor in the Department of Civil and Environmental Engineering. Our research really delves into the materials durability and corrosion durability of our infrastructure. So, corrosion of our infrastructure is actually a very expensive problem. The GDP, the gross domestic product, is a number that represents how wealthy of a country is. And so in most Western countries and developed countries, the cost of corrosion is about 3% of the GDP. So it ends up being a very expensive problem. And a large part of the corrosion problem occurs actually with our highway bridges of many different things. So the estimated direct cost of corrosion for our highway bridges is about $8.3 billion a year. So it's a very expensive problem, money that can be well spent in other places, especially for our social services, especially if a lot of the causes can be prevented. And so we use many different types of construction materials in our infrastructure. Primarily, we use steel and concrete. And one building technology we use is reinforced concrete. So we know that concrete is a very good material. It's very good, especially for compressive forces, but it's not very strong with tensile forces. So typically, we put reinforcing steel to carry some of those tensile loads. But you can see in the pictures on the right-hand side that when you have salt water, for example, and chloride ions coming from the marine environments, or even de-icing salts if you're in the northern states, that chloride ions come and they attack the steel and cause corrosion. And you can see the expansive forces from that corrosion causes the steel to not only lose its cross-section, but also cause spalls and cracks and delamination in the concrete itself. So you see major sections of the concrete pile, in this case, broke off and fell into the water. So it can be a very disastrous structural problem and something that we try to mitigate. I have some more pictures showing to you, again, the extreme damage caused to some of our substructures due to corrosion. Here are some pre-stressed piles. You can see the pre-stressing strands and how they're completely broken through. an attempt by some bridge owners to try to mitigate these systems. In this case, in the left-hand picture, you see they try to actually install new piles just to support that pier where they have a major structural damage. On the right-hand pictures, you also can see how there are large structural cracks that can occur due to corrosion. This will lead to further exacerbation of problem and more structural problems. There are different techniques to try to mitigate these problems. In the bottom right-hand side, you can see these pile jackets. Some technologies, they look at using electricity and almost creating a battery, if you will, to try to protect the steel underlying to prevent further corrosion. But this is an expensive process, needs a lot of time and effort and monitoring the system to make sure it isn't effective. So we continue to look for new technologies and different ways to better protect our structures and how to reinforce our structures as well. Other systems include post-tensioning systems. In some of our bridges, we use high-strength cables to hold the structural elements together. In these pictures, you see here how corrosion can come in, even in these protected areas that are within these box girders, can have major corrosion damage, severe corrosion happening in less than 8 years, for example. Very dangerous and cause a lot of problems. You can imagine these tendons, they're about 4 inches in diameter. They're filled with 22 7-wire strand filled with grout materials. So it's like a cementitious material. Very, very rigid structure. But the force of the corrosion loss was so severe that these elements end up becoming like curlicue fries. So much stress was released that it completely distorted these very rigid structures. So it's a very dangerous issue. Not only on our superstructures, some of our structures that are buried on the ground have some materials issues that can cause corrosion. I have some pictures here of a tunnel lining. The tunnel lining here has some cracks. The cracks allow some of the salt water to seep in. You can see the moisture penetrating through. They have some of these materials coming out. You see it seeping. It's called efflorescence. It's the development of cementitious materials that react with the water and comes outside. It can be a possible future corrosion problem. Some of our MSE walls and mechanically stabilized earth walls sometimes have problems. The steel parts you see here are part to reinforce that wall to keep it from falling over. You lose lose those steel components due to corrosion, you lose structural integrity. Other materials include steel components. We do have steel bridges in Florida. You can see how paints and protective coatings are mainly used to prevent corrosion, but you see they continue to deteriorate. Indeed, in the state of Florida, we have every year a large number of paints that need to be redone. And the cost typically is about $26 million annually just for repainting our bridges to try to prevent some of these corrosion issues. So in our work, we try to understand the corrosion problem and try to give recommendations on how to prevent corrosion and solutions to fix the problem. And an area that we try to look at even in the ABC program. So I thank you for your time.
All right, thank you. Thanks a lot, Kingsley. All right, great. So let me just very briefly, just to show you some of the work that I will be doing myself, and then we'll open it to questions that anyone might have. Okay, so I am pretty much, I don't know, good, bad. If my name is somehow associated, if you mention my name at the national or international level, they're going to say expert in the steel bridge. But nowadays, actually, I do probably 90% of my work is in the ultra high performance concrete area, developing solutions based on the ultra high performance concrete or a UHPC. One of the projects that I will be working with many faculties, actually, this is not just one person is not going to be able to do this. This is the working with many faculties, and not only at FIU, but also at the different partner university, is going to be the next generation of the asset management system. This is in the US, we have a system that basically every 2 years, every state have to inspect their bridges and then send the data to Federal Highway Administration. A National Bridge Inventory database basically is used to kind of monitor. And actually that is used for how the states get the money. So, but it's time to develop the next generation that makes and this is one of the ways we are going to try to make the bridge industry in the US to be absolutely number one. There's going to be many components to it. You can probably the CTR. I mean, there's many aspects, the repair of it, the twin digital models, the advanced analysis system, automations, and everything else. So if you look over here, basically, I mean, in this, you're going to have to, in the next generation of the bridge asset management system, you're going to have to bring the artificial intelligence. You have to have a decision-making process, like Dr. Ibrahimian was saying, that you're going to have to include the social equity, the climate change. You're going to have to use advanced materials to repair and upgrade the next generation of the bridge systems, that is make it easier, and automations and so on. So I personally work with many faculties that we have, many faculties outside. So you can talk to some of my students to get some idea, or go to structures lab. I think that will give you a better idea. So with that, let me just open it. If anyone has any questions to any of our faculty or myself, I will be happy to accommodate that. So any questions, go ahead and ask. And if there is no questions, really, I guess I don't see anything on the chat box, so we can conclude. Again, thank you for attending this this information, the webinar, the Zoom meeting. As you can see, there is a really, when it comes to structural engineering, bridge engineering, infrastructure, really FIU is one of the best universities in the US that you can get educated. It's the infrastructure, bridge engineering, it's a multidisciplinary, requires expertise in many different areas. And as you saw, our faculty here works very collaboratively, not only here at FIU, but also with the universities around the country. So again, thank you for your time. And please, if you saw something that interests you, approach the faculties directly. Their office is always open to you. Talk to them, see what they are doing, keep track of the activities that we will have in the future in the IBT/ABCUTC. There are many opportunities for you to gain some really good experience and beef up your resume for getting some really great jobs in the future. All right. So with that, we will conclude the webinar. And again, thank you for attending this Zoom meeting. Thank you.